I'm Najaswat for BizNews.com, and joining me today is Dr. Valter Longo. He's a professor of Gerontology and Biological Sciences at the University of Southern California and the director of the USC Longevity Institute. Dr. Longo, it's a pleasure to have you with us.
My pleasure.
You're world-renowned for your research on aging and longevity and your work on the side effects of fasting and diet on health and disease. It's a very particular specialty. What drew you to it?
I just thought that longevity and studying aging was so important scientifically, and at the time, I think it was a little bit futuristic, at least in the early 90s. But I also thought that aging was at the center of all diseases, and so it was in fact surprising that everybody else was not working on that, right? So why was everybody waiting until a disease was diagnosed and then trying to do everything possible desperately, rather than working on the aging process and intervening and trying to avoid the disease in the first place?
Well, your work led to the development of the fasting-mimicking diet. So can you just explain the concept to me and the practical steps that it entails?
Yeah, so for a long time, the aging field has known something called calorie restriction. And calorie restriction is really about reducing calorie intake chronically. And that's been shown to have all kinds of effects that slow down aging and also reduce age-related diseases. But calorie restriction, let's say in humans, it would be equivalent to eating 25% less than normal. Not less than excess, but less than normal. And so we know that that's just not feasible. It will cause most people to be very, very low body weight and muscle mass, et cetera, et cetera. And so for a long time, for 30 years, since I was working in the laboratory of Roy Walford that was working on calorie restriction, I started thinking about replacing this. So is there something that we could do once in a while and that would be as effective as this everyday calorie restriction? And so that's where the fasting mimicking diet came. And so the idea is to do, let's say, 4 to 7 days of this relatively high calorie, calorie restricted, but relatively high calories. So it's about 1,100 calories going to about 800 kilocalories per day. And so you're eating about half of the calories that most people normally eat. And you do it only, let's say, once a month to once every 6 months, right? So yeah, otherwise keep the normal nutrition and use this periodically. And now we're shown to be working very well against diabetes, against prediabetes, against some inflammatory diseases, and also in mouse. I mean, these are the clinical trials. But in mice, we're showing actual multi-system regeneration. We see the ability of this fasting mimicking diet refeeding cycles to be able to turn on stem cells, but also to reprogram normal cells, make them younger, and make them rebuild what's been damaged by aging or by toxins.
So it's these clinical trials that you've done using mice that are giving you hope for the potential applications of the diet on prevention and treatment of disease.
No, the clinical trials are human clinical trials, right? So now we're at clinical trial number 4, finished for diabetes and prediabetes, and all of them show the same, right? So this is done once a month to once maybe every 2 months. It's very effective in the diabetic and prediabetes population in reducing A1C and in fact in getting a lot of people to reduce drug use. About 70% of the patients could reduce drugs, and then and the idea is within a couple of years they get them back to normal, and so they're healthy again. So they're in remission. And in cancer, there's also about 10 clinical trials that have been completed, human clinical trials. And some of them have shown some remarkable effects in making chemotherapy work better, making the immune system more aggressive against the tumor cells. So yeah, in cancer, of course, there's a lot of cancers, a lot of therapies, much, much more difficult than diabetes to address. But it looks very promising, and it particularly looks very promising as a as an intervention. The fasting mimicking diet is an intervention to make all kinds of therapies work better or a lot better.
But what are the mechanisms of action at play that enable these kinds of defenses to diseases? Some of the criticisms and concerns against fasting is a weakened immune system, nutrient deficiencies, and fluctuations in blood sugar levels, which is particularly dangerous for people that have diabetes. So have you conclusively found out what the body does during fasting that enables it to better defend itself against disease?
Yeah, so fasting doesn't really mean anything. I always say fasting is like eating. And so people that attack fasting, it's like attacking eating, right? So, we're talking about fasting mimicking diets and that are being carefully designed, tested in a lot of animal studies, and tested in randomized clinical studies. And so we're talking about a little bit like the FDA process with large randomized trials. And then, you what works and what works without side effects works without side effects. Everything else just doesn't mean anything, right? Because journalists should really stop talking about fasting because it's irrelevant. It's very good for you or it could kill you, right? So it depends on who you are, what conditions you're in, and how you do it, right? So yeah, so of course the process is very careful, and we've been working on it on cancer, for example, for nearly 20 years now, and so now we're starting to see lots of cancer centers around the world, either through clinical trials or also in practice. Some university hospitals and other clinics are now using the fasting mimicking diet and fasting standard with the standard of care in their treatment of patients. But so how does it work? I mean, it works in all kinds of ways for all kinds of diseases, right? For example, for diabetes, it's something very simple. Diabetes really, at the foundation is diabetes is a normal process, right? So in the summer, we used to eat a lot of fruit, a lot of nuts, a lot of honey, and gain weight, right? And this weight gain was necessary to get over the winter fast, right? So in the winter, eventually, you would go through periods with no food at all. And this is emperor penguins in the South Pole, for example. They still do this every year. The males, they go a couple of months with no food while they're incubating the eggs, right? So as a necessity, and during those 2 months, if they did not have excess fat, they would die. And so it was the same for us, right? And so now it's interesting that this should be the foundation of any endocrinology and diabetes clinic in the world. It's not, but so eventually to unlock that the obesity storage, the fat storage period, you have to go into a fast. But if you go too long of a fast, now you go from burning fat to slowing down metabolism, right? So it's really much more trickier. This is why I was saying it takes a lot of work and it takes a very careful design. So if you go, let's say, 3 weeks with no food, yes, you get a lot of gain benefits, but then you get a lot of danger situations, right? Like hypoglycemia, some of the things you talked about, but also you get the probably enter a hypometabolic state. What does it mean? That the system is so worried about starving to that it's going to start burning less calories, and now it condemns you to regain all the weight that you lost, right? And even more than the weight that you lost. So yeah, so it's I think this is just diabetes, then cancer, then autoimmunity. It's about understanding the molecular biology, but also understanding the evolution of fasting and where does it come from and what it is able to do. And so, I mean, for each disease is a different story.
Well, in respect of the evolution of fasting, I mean, I understand how it does still apply to emperor penguins, for example, and how many, many years ago in the earlier evolution of man, we had to, by default and conditions, fast as a result of winter and our circumstances and capabilities at the time. But that is no longer applicable to where we are at this point in evolution.
Well, that's exactly it, right? So that's exactly the problem, that people don't do that anymore, right? So they used to do it. And even 1,000 years ago, the Christians, and we still see it, so some Muslim and some other religions, right? But even the Christians, up to 1,000 years ago or so, they were all doing 6 weeks of calorie restriction, ending with 1 week of fasting during the Lent, right? So during Easter, in the Easter period, and but that's gone, right? And so yeah, nobody does any of this anymore. And but obviously that's a fundamental part of metabolism, meaning that okay, you gain the weight, you put away the fat, and now 72% of Americans and about 50% of Europeans are overweight or obese, right? So okay, now the winter comes, and then you have to do this fasting period, but the winter never comes, and that's why people are going to be insulin resistant, pre-diabetic, diabetic, metabolic syndrome, and that's getting to be close to half of the world, and so I think we need to more so now, we need to go back and have intervention like the fasting mimicking diet, so that yes, the winter doesn't come, but at least you have something that reminds the body about the winter mode, and switches it back, so that we don't continue to accumulate fat, but also so that we don't enter a low metabolism mode that really condemns us to regain all the weight.
So is it fair to say that we are really just helping our bodies consume food in a way that we were predominantly evolutionary primed to do?
Yeah, so it's basically the way the fasting mimicking diet, that we designed the fasting mimicking diet, is to be respectful of what happens during water-only fasting, but also simulate some of the food that may have been available, or the type of foods that may have been available during those fasting periods, let's say vegetables, for example. So the body during the fasting period doesn't mind fat, right? And it's working, it's using fat and ketone bodies and fatty acids as fuel. And so that's what we use. We use that knowledge that proteins, and particularly certain amino acids within the proteins, are going to interfere with the fasting response. Sugars are going to interfere. So we have a period with low sugar, low calorie, low certain type of amino acids, high levels of fat, right? So then the system recognizes that as an environment that it understands as if it was fasting, right? But at the same time, we want to prevent these extremes, whether it's very low blood pressure, very low glycemia, and also the compliance. And most people are not going to be able. I've done water-only fasting once, and I can still remember every moment of it, right? And it was extremely difficult for me. And I always thought I'm never going to do this again. And so I think that learning from my own experience and talking to lots of people, we felt it was very important. And also we started the fasting mimicking diet actually many years ago when we started the first clinical trial on cancer patients. And we thought, of course, the cancer patients are highly motivated, they're going to do it. And we realized that water-only fasting, not only the cancer patient did not want to do water-only fasting, the oncologist did not want them to do in our own hospital, right? So that was the where we understood that it's not as straightforward as you think, right? People like to eat, and even though you have cancer, even though your life is on the line, lots of patients did not want to go through this 4 or 5 days of water-only fasting.
Your fasting mimicking diet, though, is materially different from other versions of fasting, particularly intermittent fasting. It doesn't, as far as I understand, involve eating no food. What are these material differences? How does it stand out from the rest?
Well, again, fasting, there's all kinds of fasting is just not eating, right? So intermittent fasting, I think there's a few. So first of all, what is the advantage of the 5 days, for example, for regular people? Well, one of them is that it's not too long. We have no evidence that it gets you into this hypermetabolic state, right? So there's enough food, and it's not long enough to make your body worried about preserving energy. But it's also long enough, and it takes about 2 to 3 days to start burning a lot of fat and to turn into a ketogenic mode, right? So If you do fasting for 1 day, you're not even going to enter that. Most of your body's got glycogen, it's got glucose reserves to get through it. So then it takes about 2 to 3 days. This is why 5 days. And also we like the fact that after day 2 or 3, the patients are no longer very hungry. So you're hungry for the first 2 or 3 days. So let's say that you did 2 days of fasting, and there is some practices that do that. Well, now that's 2 days of a very difficult time with very little ketogenesis, right? And so that's why we don't do 2 days. We go with 5 days. And also autophagy and stem cell activation. So there is a lot of the molecular processes that begin to happen after 2 or 3 days, and then we want to push them, to the type of level that optimizes benefits without making it difficult on the patient, and also without potentially causing safety issues.
Now, during these 5 days, what are you allowed to consume? Whether it's liquids or types of food.
Yeah, so in 5 days, we recommend to people that they do what's clinically tested. When I wrote my first book, The Longevity Diet, I try to not give recipes, but certainly explain. And that was a disaster, and because what happens is fasting is extremely powerful. And so it can be work in your favor or against you. And so that's when we realize we should not be giving recipes. And people think, but this is companies and commercial interest. That's not the point. The point is that what's been clinically tested should be the only thing done, and otherwise you're going to see the medical community go against it and block it, and for good reasons, So I would say just do what's been clinically tested, and that's it. These interventions are not that expensive. Most people are going to do them 3 or 4 times a year at the most. So I think that I would recommend that they stick with what's safe and clinically tested.
What sets apart those people that have a good experience with fasting from those who don't? Is it linked to incorrectly following the diet, or are there any biological predispositions that influence the effects of fasting?
I mean, it's too early, although maybe more than 1 million people have done the fasting-mimicking diet the way we designed it. It's hard to know, right, at this stage. We do see people, for example, if somebody's a vegan and is used to eating a lot of very healthy food, and they have no problem at all, right? But if somebody eats 10 steaks a week and hamburgers and fries, the first time is tough, right? So then it makes sense, right? It makes sense that somebody that is not used to any of this food and is used to food that is very tasty, and it just has a heavy effect on the tasting, those are going to have a harder time. And but also it's true that the vegans that do everything right and they're in perfect shape, we really don't see much of an effect, right? So not that there isn't one, but it's not that apparent. The ones that come in with all kinds of problems, they do struggle a little bit. If the first time, they struggle less the second time, less the third time. And that's where we see big effects, right? So even in the first publication in 2017 clinical trial in humans, we saw by far the biggest effects on those that started with high fasting glucose, high cholesterol, high blood pressure, high inflammatory markers. So I think it's interesting, right? So the people that have no problem doing it have less of a benefit.
On the topic of steaks, you are not a proponent of a high protein diet. You came to the conclusion that individuals under the age of 65 who have a high protein intake are more likely to be receptive to developing cancer. Firstly, what was the sort of premise of that study? On what was it based?
Yeah, so the study basically looked at the Americans that consume the highest level of protein versus the Americans that consume the lowest level of proteins, and then look at age at different ages, right? So it turns out that the mortality from cancer, the risk of dying of cancer was 4 times higher, and there's a special formula to to describe or define risk. And it's not just whether you're going to get cancer or not, but when you're going to get it. Are you going to get it earlier or later? So that risk, as it is defined formally, went up 4 times in those that had the highest protein intake compared to those in the lowest protein intake group. It was no longer true for the 70, 80, 90-year-olds, which actually did worse if they were on a low protein diet. And so we explained that by, and in mice, there are similar results. And so we explained that because some of these growth factors that proteins increase, they're no longer increased in the older individuals because they're already so low that the high protein intake is not able to get them to be very high, right? So aging is so problematic for these growth factors that they seem to be promoting cancer that, a low protein diet is no longer beneficial. And in fact, it may make you malnourished.
I've extensively covered Professor Tim Noakes' work, and he's settled on a high-fat, low-carbohydrate diet. It's high protein. So I am partial to understanding the premise of why high-protein diets are very good. Where do you stand on this whole debate between diets?
Yeah, I don't think it. I mean, I always say whenever you get people that really look at all the data, we all pretty much agree. But I think in some cases, this is why my books are based on what I call the 5 pillars of longevity. So I look at, epidemiological data, clinical trials, basic research on aging, and centenarians, and then complex systems. So when you look at all the data, I think it's pretty clear. And I think, it's just many studies, right? So if you want to make a mouse live longer, you give the mouse a low protein diet. You don't give the mouse a very low protein diet because then you get the mouse to be frail. So I think that the meta-analysis, like the studies of all studies, are very clear. A low-carb diet are going to kill you earlier. And unless, and this is Harvard School of Public Health, is Lancet, it's just over and over and over and over, So, and the ingredients over and over and over, whether it's China, Europe, the United States, seem to be high legume, high whole grain, high nuts, and low no or low red meat, and usually local, right? So it's pretty clear that that's the in the absence of malnourishment, that's the ideal diet for the great majority of people. Now, it doesn't mean that people have to have the Mediterranean diet or the Okinawan diet. I think the different places are going to have their own, so somebody may be allergic to gluten, or intolerant, or even have an autoimmunity, celiac disease, right? Somebody may be sensitive to gluten. Somebody may be sensitive to tomatoes. And so I think that, within the general idea that this mostly vegan, but probably pescatarian, either pescatarian or having some meat included, that seems to be the ideal diet. And then within that, you have to personalize, and you have to see, what am I dealing with, right? Am I dealing with a vegan that eats too little proteins? And, so some amino acids, for example, in legumes are 5 times lower than in red meat, right? So if all you eat is low level of those legumes, you're going to become malnourished. And so I think there's a, I don't know why, but the nutritional field, I mean, this used to be true for the neuroscience field. Like 50 years ago, people thought neuroscience was a crazy field. Like, why would you start with neuroscience? We know nothing about the brain. It's a crazy field. Well, not anymore. Neuroscience is a very legitimate and very, one of the most interesting fields. But nutrition and the biochemistry of nutrition is the same way, right? It was historically, it was just like it's food. why are you even studying this? And now it's like, no, this is every component of the food is gonna trigger different responses in different genetic pathways. And and so now you have an incredibly complex system, the human body, and an incredibly complex environment, which is the food environment, right? And so then they encounter each other, and so that's where we're starting to need artificial intelligence, etc., to even handle it. But until then, I think this 5-pillar, very more sophisticated approach is necessary. Otherwise, you just get lost. Just looking at a couple of studies and saying this is good and that's bad, it's just really pointless.
I'd like to eventually get onto the points made in the Longevity Diet book. But just lastly, on the fast mimicking diet, it's also said to assist and be very beneficial to help with neuroinflammation and chronic diseases such as Alzheimer's. First, if you can clarify what neuroinflammation is, what diseases are the result thereof, and what your findings are in respect of how this can help those chronic diseases and Alzheimer's.
Yeah, so neuroinflammation is basically the immune system or component of the immune system that are overly active, and maybe for a good reason in the brain, maybe for a good reason. Maybe they're trying to get rid of beta amyloid or other proteins or peptides that have been accumulated in the brain, right? So, but some of these are difficult to remove and or impossible to remove, and that's where the immune system may get into a state of continuous chronic inflammation. And so we and others have been showing that that inflammation seems to be at the center of the damage that occurs in Alzheimer's disease, at least in mice. But I think most people are now agreeing that that's probably also true in humans. And so the fasting-mimicking diet, when we look at mice that are genetically predisposed to get Alzheimer's disease, have the human mutation to cause Alzheimer's disease, and they cause a lot, even in the mice, they cause a lot of neurodegeneration. So we see the fasting-mimicking diet reducing many of these neuroinflammatory pathways or markers. And so the cognition goes along with it. So the mice, even though they're full of these mutations, they do a lot better, and they remember a lot better, and they perform a lot better. So now we are close to finishing a clinical trial in two hospitals in Italy on Alzheimer's patients. And the good news is that most patients could do this once a month, and we were surprised because they're fairly old or very old. But they could do it. They could do it, but we don't know the results yet. But we do think that the pharmacological intervention for Alzheimer and cognition so far have mostly failed, and I think just like we're doing for cancer, and just like we're seeing also for HIV, for example, that you need multiple interventions, right? I mean, in the case of HIV, maybe not nutritional intervention, but I think in the case of Alzheimer, the metabolic nutritional intervention together with the drugs, my guess is it's going to be much more powerful in the long run, right? So can you sort of rewire the brain metabolism as we know we can do with the fasting mimicking diet? And then what are the drugs that may cooperate with this rewiring to make it even better? Just like in cancer, we hardly see any great effects of fasting mimicking diet alone or of drugs alone. But when we combine it with this chemoimmunotherapy, kinase inhibitor, hormone therapy, then they really do wonders together. So I think that's what we're going to see for Alzheimer.
Insofar as taking a comprehensive approach, I've looked into the effects of gut health, and there's a lot of inflammatory conditions that exist here as well that permeate throughout the body. Has your research taken anything gut-related into account?
Yeah, so we published a paper on inflammatory bowel disease in mice, and now we're doing several universities. I know Stanford and I think University of Miami. They're both testing the FMD and inflammatory bowel disease, and in mice it worked extremely well, and it caused reduced inflammation, increased the stem cells of the gut, and then also change the microbiota. So the cycle, and interestingly, the water-only fasting did not work so well. It increased the leakiness of the gut, and the fasting-mimicking diet, maybe because it's got a lot of healthy prebiotic ingredients, plant-based, and by the way, the FMD is 100% plant-based. So maybe because of that, it made the gut less leaky and also promoted more of a regeneration of the gut compared to the water-only fasting. So yes, I think it's certainly very promising. But thus far, we don't have. We have anecdotal evidence from humans, and we treat a lot of patients in our Create Cure Foundation clinic with the autoimmunity and inflammatory bowel disease. So we see a lot of benefits there, but nothing from a formal clinical trial yet.
I'm going to just focus on one point from your book, The Longevity Diet. The diet can promote stem cell regeneration, which can have a range of benefits for health and longevity. What part of fasting and the longevity and fast mimicking diet is it that helps get to the point of stem cell regeneration?
In mice now, we've done it for the gut, for the pancreas. We've done it for the immune system, the blood system. We've seen evidence in the brain. So it's very clear, right? And it's actually a very simple concept, which I always say I'm very surprised that nobody has ever thought about it until we published it. But the simple concept is the following: a mouse or a person, after so many days of fasting, it starts shrinking, right? You'll see the white blood cells in your blood start coming down, and your muscle and every organ beside the brain, and probably lots of cells within the brain, also start to change and shrink. But the brain size doesn't shrink. So now you shrink, and but at some point you're gonna start refeeding, right? And so in the refeeding moment, and for example in the mice, right, we see the shrinking, and then let's say we damage the pancreas. Well, if we damage the pancreas and we get to the point that it's no longer making insulin, permanent, right? So permanently damage the pancreas. Then we start the fasting-mimicking diet cycles, and you see the cells reprogramming, and they're turning into stem cell-like pancreatic cells, and then they start making new cells, beta cells, and make normal insulin. So you just completely reverse this permanent damage in the pancreas, and now again we see it in all kinds of organs. So yeah, then in the re-expansion, it makes sense that you have to generate new tissue, new cells, or new functional cells, and you go back to the embryonic developmental programs to do so. And that's why we see all these genes, like these Yamanaka factors, for example, right? These factors that are used to make a normal cell, turn a normal cell into an embryonic-like stem cell. And we see them turn down, and then we see this many of the genes that you only see turned down during embryonic development. That's how we know that this is probably it's using the developmental-like program to rebuild at least part of the organ or system.
And this, I'm assuming, has an unlimited amount of potential for human development.
Yeah. Obviously, if you think about a child, right? So you think about, I in my book, I show like 2 45-year-olds, right? That they generate a child that is starting perfect from zero, right? So that, what does it mean? It means that obviously all the information to start from zero are, within the 45-year-olds, even though they're 45-year-old. And so then the idea is, if you have damage in one or many systems, why don't you use that knowledge to repair it, right? And to rebuild it and to replace it. It's much harder to do it than to say it. But, obviously now we see the fundamental ability to do so the body can regenerate and repair itself. But we knew that, right? Like if you cut yourself, 2 weeks later, perfect, right? And I always say, imagine if you took the best biohackers in the world, how long will it take you to get that repair as well as what the body already knows how to do, right? Probably it's about a 50-year project and trillions of dollars to repair a cut as well as the body knows how to do it, right? Yeah. So then what about the liver? What about the gut? What about the brain? Is it the body doesn't know how to repair any of that? Well, maybe it does, right? But how do you get it to do it well and do it completely? There's a lot of difficulties, and but I think it's the foundations are there, and I think we're very enthusiastic about all the uses that can come from this. This was the center of every religion that you can think of. So I think that this is a very natural process, and the question is, how far can this go, right? If you're thinking about, am I going to make somebody live to 150 years of age? That's not going to happen. So at some point, as I was saying earlier, the biohacking comes in there, and then that's the more ethically controversial part, right? So when you want to make this process unnatural, then that's a different story, right? We are now moving into a very different level of research. It's gonna, I think, accelerate tremendously the speed of research and longevity, and that's good. And hopefully that also translates very quickly into keeping people away from hospitals, and not what we have now is most people taking multiple drugs and being chronically sick. So I think that hopefully in the next 10 years, 10, 20 years, we're going to start seeing this longevity research making a big difference in people's health, and start moving the population into, I'll stay healthy until I'm 110, because that's how sophisticated the interventions are, and not just taking pills all day long.